This is Professor VTQuan. I'm come from the Department of Mechatronics, Ho Chi Minh City, University of Technology, and welcome to my class. This is the Mechatronics Systems Design course, and in this chapter, I will give you some information about some fundamental knowledge that you need and you have to review to carry on this course. Firstly, we will discuss something about my classroom. And the first thing in the classroom that we have homework and class exercise, and the evaluate rate for this is about 40%. And all of you have to submit the homework via the e-learning system of our university. The second thing is teamwork project. The evaluate rate is about 20%. You have to choose your team, and each team will include 4 students. And I will give you the topic of each team, and you have about 10 weeks to prepare for your presentation, and your presentation will be take in the 2 final weeks of the semester. And I encourage all of you, you can use the English presentation for your PowerPoint. And finally, the final exam is about 40%. You will allow to use your paper document while doing the exam. And the time for the exam is about 90 minutes. And if you have something to comment or something to ask me about this course, please come to my office about office hour. It's in the slide. Okay, so this is classroom, and the next one will come to some class material. And the class material for this course is about my lecture notes and some books I will list here in the slide, and I will upload on this book for you in the e-learning website. Okay, and finally, some fundamental knowledge you have to know, because all of this knowledge you already studied before in the last semester. So you can see that mechatronics is we need to integrate and combine many different areas together, and to make a complete system, including the mechanical parts, the controller parts, to operate your system to work perfectly. Okay, so in mechatronics, you need the knowledge about, firstly, this is the most important, this is the mechanical knowledge. Okay, so all of the mechanical knowledge you already studied in the last semester before, right? So in the mechanical, you need to have your idea, and then from the idea, you have to think about how to make your idea, how to become real and design. You have to make the mechanical, for example, if you wanted to make a automation system, and you have to think about the automation system from your idea, and from your idea you will design your automation system. Okay, and the second thing is about the control theory. And in control theory, I think that all of you know about this one. This is the PID. Okay, all of you already know about PID, and we did study many things about PID in the last semester, and especially in the course name Dynamic System and Control, right? So besides, if you have some more knowledge about some other advanced controller like IVR, IVGs, or FOSI or something, or advanced control is better for you. Okay, and the third knowledge that you need to know, this is about the computer science. You need to have the skill of programming in C++, C#, or Python or something. And one of the most important program that you need to have the knowledge is MATLAB, because we need to use MATLAB to simulate the operation of your mechanical system, or of your robotics, or your automation system. Okay, and finally, you also need to have the knowledge about electrical and electronics device. This is similar to the mechanical, because, for example, when your customer come to you and ask you to design something for them, and you have to think based on their requirement, what is your mechanical part, and what is your controller, what is your electrical and electronic. So everything you need to have from your idea to design. And about this part, you have to know about how to calculate the power circuit. Okay, the power circuit and the control circuit In power circuits, you need to know some special function circuits, some special IC, some special electronic device, something, okay? And all of this one, maybe you already studied in the course automatic control system, right? And about the control circuits, you need to have some knowledge about microprocessor, microcontroller. All of you already know about this one, okay? And maybe PLC, or we use another stronger controller. This is embedded PC. And finally, for the mechatronics knowledge, you need to have the mechanical knowledge, control theory knowledge, electronics knowledge, and computer science. And as I said before, the most important thing that you have to simulate everything in your computer. We simulate the operation of your robot, simulate the operation of your mechanical system to evaluate the response. Is it good or not? Or we can evaluate the agreement between the mechanical and the controller. Everything we do in the computer environment, okay? And then based on the simulation, we will conclude something. It is good, it is suitable, it's bad or not or something, and we will have some conclude to correct something about the mechanical, to correct something about the control theory, or something relating to electronics circuit, okay? So this is some fundamental knowledge that you need to have. And everything here you already studied in last semester, okay? So now we move to the conclusion of, or the main point of the mechatronics. So you can see that the main point, or I can say that this is the most powerful of mechatronics. This means that in mechatronics, you can simulate the operation of the automation system or robotic in computer. This is the most important because let's think about this. When before you fabricate or manufacture a robot or an automation system, everything you have to check. You have to check everything to make sure that everything works perfectly and everything is matched together. Especially, you need to check the agreement between the mechanical part, the electrical part, and the controller parts. So, the most powerful of mechatronics will help you to do that, because in mechatronics idea, everything you do in computer, and based on the simulation program, you can have the response of the robot or the response of the automation system. Another time you can evaluate the feasibility of your solution, to evaluate the suitability between the mechanical system and the controller system of your design, okay? Or it can help you to find a suitable controller for your system. And one more thing, based on the simulation system, you can predict the operation of your system in the future. What will happen? Is it good or not or something? And you will, based on this response, based on the simulation result, you can have some innovation idea to make your mechanical part better, to make your controller part better. And finally, you can have a very, very good design system. Okay, this is the main point of mechatronics. Okay, remember? So, we move to this slide. I will give you some review of your knowledge, because all of this knowledge you already studied. But when you come to this subject, this is the Mechatronics System Design. This means that in this course, you have to integrate everything you know about mechanical, everything you know about electrical and electronic, and everything you know about the controller, and you have to combine, you have to integrate all of them together. And that's why before you do this work, you have to understand everything perfectly or clearly, okay? So in here you can see that I write a word here, discriminate between these concepts. discriminate between these. You have to discriminate this concept clearly, okay? Because this concept, they have some, if you don't understand or you misunderstand some knowledge about this concept, you have big problem, okay? And you don't understand well, and that's why you cannot design a system, okay? So firstly, we talk about the kinematic and dynamics, okay? This is the most important, because from the mechanical part of a robotics and the mechanical part of an automation system, okay, we can get, or when we can derive the kinematics or dynamic equation of your mechanical system. But the problem is that when or why do we use kinematic, or why do we use dynamics? Okay, if we just pay attention to the position only, okay, the relationship between the position of this part and another part in your system, we use kinematic. But if you wanted to consider about the velocity, acceleration, the speed or something, you have to pay attention to the dynamics. Or I can talk an easy way for you to understand. If you wanted to consider something internal of the system, okay, so we can use kinematic. But if we consider something external, for example, you have an external force impact to your robot, we need to do the dynamic. Okay, for example, you have a manipulator, and you use your manipulator to carry one object from A to B, from the start position to the end position. But the weight of the part is not changed. It's not changed. So at that time, you can use kinematic. Is okay. Okay, it's only simple kinematic. But if I change the weight, and the changing weight of the object that we don't know, so at that time we have to use dynamics to analyze your system. Okay, understand? And the second, this is a linear system and non-linear system. Okay, the idea or the knowledge about this one, all of you, I think that all of you already know, and you already studied many before in the dynamic system and control course, or on automatic control system course. Okay, so about linear system, what is the linear system? In theory, we can say that you already studied in the automatic control course. The linear system is the relationship between the output and input in the first order equation, right? And then if this relationship is expressed in the mathematical equation, not the first order, the second order, or third orders, this is a nonlinear system. Okay, this is the theory. Okay, but practically, we can say that very easy. Okay, in linear system, this means that when we consider or when we analyze a system, and we know that the behavior of this system at this time t, and the future time t plus 1 or t plus 2 or something, this means that the relationship between input and output, they have a fixed equation, and every parameter in the equation doesn't change. This is similar to the equation of the mass spring damper system. Okay, the mass spring damper system. All of you know the mass spring damper system. If the stiffness of the spring is fixed, the damping value of the damper is fixed, the weight of the mass is fixed, and the force is the output force. Okay, but when we write the equation of this system, this is the linear system. Okay, and about non-linear system, it's the inverse with the linear system. If something that we just only know the behavior of the system at present time, but in future time we don't know. So we can conclude this is a non-linear system. For example, we come back to the mass spring damper. If here I change the spring to the torsion spring, this means that the stiffness value of the spring we don't know. Or we can change the weight of the mass, okay, to another arbitrary value. That means we don't know. This system will become non-linear system. So the most important thing when you analyze a system, the first thing you have to discriminate this system. You need to analyze about kinematic or dynamics. The second one, you need to figure out this system is linear or non-linear. Okay? Because if a linear system, you will choose a linear controller for it. If this is a non-linear system, you will choose a non-linear controller for this. Okay? You cannot use a linear controller to control a non-linear system. Okay? Understand? Okay? And the third one, in controller problem. Do you know one of the most important factors in control system? This is the sampling time. This is the most important when you do the controller. Or when you do the real control for your system. Because the sampling time is very, very important. If you choose the wrong value of the sampling time, even though your kinematic or dynamic equation is correct, your controller is correct, but you cannot find the agreement between the mechanical part and the controller parts. This means you can see the result. This is the response of the system. It's not good. And that time you will think that you have something with your mechanical part, or you have something with your controller. But it's either sampling time. So based on the simulation environment in computer by using MATLAB, you can choose the suitable sampling time for your system. I mean, in your system here, this means totally your system, including the mechanical part and the controller part. Because remember, if you choose the wrong value of sampling time, you cannot find the agreement between the mechanical and the electrical. Because the mechanical response is low, but the response of the electrical is very fast. Okay, understand? So, and number 4, I will talk about the controller. All of you need to know very, very clear about what is the controller. Because, because actually in your thesis, you will have the one chapter. This means that controller design. So in this chapter, what will you write in this chapter? Okay? This means that you have to understand very clear about controller. What does that mean? Okay? What are the components of the controller? Okay? So controller including hardware and software. Okay? Hardware means that, for example, you use PLC, you use microcontroller, you can use your PC to control your robots, to control your automation system. But if you don't have the control theory to input into this hardware, this means software, it cannot become the controller. Understand? So, I mean that controllers including the hardware part and also your knowledge, your know-how, your control theory. You will input this control theory into your hardware to make it become a controller. Okay? And number 5, communication standard. Why do we need the communication standard? So, we need the communication standard to transmit and receive data between this part and another part, or we need the communication standard to transfer data between many controllers inside one robot or inside one automation system. Okay, so you may remember that you already studied about how to design standard controller, right? So for example, you will have the first microcontroller, you have the second microcontroller, you have the master controller, you have the slave controller, you have the PC, for example, you have the PLC. You need to transfer your data from this controller to another controller, okay? And all of these things you can do if you have the knowledge about communication standard. And at least you have to know to program for this communication standard. And I think that all of this you already studied before in the course name microcontroller. Okay, so I can list here some communication standard that you need to know. The first one, RS-232. Okay, very simple, very easy. And the second one, the improvement of RS-232 that we use in this industrial, this is RS-485 or 422, okay? And the most popular is 485. And another that you use to communicate between some IC circuits together, this is I2C, SPI, and CAN. CAN is mean controller area networks. And now we can use IoT. You can control everything. You can transfer your data via the internet environment. Okay, internet environment. All of this you need to know. You need to study. Okay, and number 6. And I think this is also one of the most important things that you need to know. This means that my question is that what will we do before we design the controller of a system? This means that you, at the time, you already have a system. You already have a mechanical system. For example, you have a robot, you have an automation system already. And now, your mission is you have to design a controller for this. Okay. My question is that before you design the controller, what will you do first? Okay. So first thing that we need to check the stability of the system. Because if your system is not stable, we cannot control. Okay? For example, if I give you a very new or a good motorbike, you can ride very easy. But if I give you a very bad motorbike, you can see the outside looking of the motorbike is very terrible. And in your mind, you will conclude that this motorbike is not good, not stable. I'm not rider. This means that you are the controller. At the time, you don't design the controller for them. Okay, understand? So the first thing that before you design the controller, you should check the stability of your system first. And one more thing, I think also is very important. This means you need to check the controllability of the system. Because if a controller or if a system is stable, but it's not controllable, we cannot do anything, okay? You need to check the controllability of the system. And you know how to check the controllability of the system, okay? This means that when you check the controllability of the system, that means you find the rank of the matrix represents for the system, okay? You need to get a full rank. Full rank means this, all the parameters of the system can be controlled, okay? Understand? And finally, the number 7. Suppose that in the number 6, you conclude already your system is stable. your system is controllable. So now we the process to design the controller. Okay, so before we design the controller, what will we do? Because you see that when we integrate the controller into your mechanical system, this means that in mechatronics knowledge, you will input the mathematical equation of the controller to the mathematical equation. This means the kinematic or dynamic of your mechanical system. And we will use the MATLAB program or some other program to simulate the operation of the system. This means that we will check the agreement between the controller and the mechanical part. And when you do the simulation, you will have the response of the system. And based on the response of the system, you can see the figure. You can see the graph of response of the system. For example, the graph of velocity changing, the graph of position changing, and you will conclude something. You will conclude that your system is good or not. You will conclude that the controller is suitable for your system or not. The controller is good or not or something. Okay, but my question is that how can you conclude? What are the criteria that you base on to give your conclusion for your system? Okay, this means that finally in mechatronics you will have the graph of response of the system, everything the response of your system, and based on this graph you will talk something. This is good or not or something. So this means that before you design the controller of your system, you need to have the controller evaluation criteria. Okay, do you remember? Based on the criteria for the controller, you can conclude that the response of the system is good or not. Because you cannot conclude anything if you don't have the evaluation criteria. Okay, so this means that in the number 7, at least here, this is the controller evaluation criteria. All of you already know about this one. So the first criteria is this is overshoot. The percentage of overshoot, how many percent? Okay, normally from 10 to 20% or lower. Okay. The second criteria is the setting time. The setting time means the time for the system from the overshoot period to the stable period. Okay, this setting time, how can we define? This is what you need. For example, when you ride a motorbike, you want to reach the velocity of about 50 km per hour in 20 seconds or 2 minutes or 10 minutes. Okay, this is your design. Okay, so based on the characteristic of your mechanical system, you will give the suitable value of the setting time. Okay, so for example, this is just for funny. For example, if you ride a motorbike and your design velocity is about 50 km per hour, but after you ride the motorbike 1.5 hour later, you cannot reach this velocity. This is very bad motorbike. Okay, understand? This is the second criteria, the setting time. And the last one is the steady state error. The steady state error. This is similar to the tolerance in mechanical, right? In control, you will see that when the system reaches to the desired value, and sometimes you will see the chattering happen. Okay, the chattering happen, but the system, you can see that it's not smooth. It will have some chattering, but the level of the chattering will be in the range of error. This is plus minus blah blah something. Okay, plus minus something. For example, you wanted to control your motorbike to the desired velocity is about 50 km per hour, but your error you can accept is about plus minus 3 km per hour. This means if your motorbike reaches to 47, it's okay. Okay? And another example, you're supposed to control the temperature of a tank, and you need to keep the water in the tank at about 80 degrees Celsius. And the characteristic of your thermal sensor is about plus minus 1 degree. This means that if you see that the response of the thermal sensor is about 79 or 80 plus 81 or 80.05, this is okay. Okay, this is the steady state error. Okay, so before you design the controller, you need to have the controller evaluation criteria, including 3 parameters. The first, I repeat, the first parameter is the overshoot, percentage of overshoot. The second is the sampling, it is the setting time. The third and the final one is the steady state error. And when you analyze the response of the system, if the response of the system satisfies all of the 3 criteria, all of the 3 parameters, you can conclude that this system is good. Okay? Because the response of the system, you see that they meet or it meets the requirement of the controller evaluation criteria. Okay? So based on this criteria, you can give your conclusion. Understand? So this is everything for the first day of my lecture. This is just some knowledge that I review for you before you enter the course Mechatronics Systems Design. And hopefully you enjoyed my lecture, and I hope to see you in my next video. Thank you very much for your attention.